Look at this magnet. It stays suspended on the stick, refusing to fall despite the pull of gravity. Welcome to Physics Sensei, Ali and Master Mayank, and today we're testing the physical limits of our world. My student Vaibhav claims you have to touch something to move it. Ekdam impossible otherwise. I told him if I prove him wrong, he owes me a plate of samosas, so the challenge is set. Does motion actually require physical contact? Vaibhav's logic is easy to follow. To move this wooden block across the desk, my hand has to provide a direct push. This is a standard contact force, or sparshball. The object exerting the force, like my hand, must touch the object receiving it. Almost every force we see every day, from walking to lifting a school bag, works this way. But setting such a strict boundary for contact forces makes them easy to test. We only need one exception to change the rule. For our test, we're using 2 ring magnets and a vertical wooden stick. These follow a specific mechanical rule. As the diagram shows, like poles push away from each other, while opposite poles pull together. We fixed one magnet at the bottom. The second magnet is aligned above it with the identical poles facing down. If the top magnet stays in the air without the bottom one touching it, Vaibhav's universal law is gone. 3, 2, 1. I release the second magnet, and it stops instantly in midair. It is completely levitating. Vaibhav is stunned. The contact rule has just been broken. This schematic shows the force at work in that empty space. The magnetic field creates a physical barrier we can't see. Gravity pulls down, but the magnetic force pushes up. These 2 vectors cancel each other out, keeping the magnet in place. This is a non-contact force, or a sunsplash ball. Much like a remote control interacting with a TV, the force travels through empty space. The hovering effect is the result of an invisible upward force exactly balancing the downward pole of gravity. By thus press down on the magnet, you can feel a spring-like resistance pushing back against your hand. Now let's flip the top magnet over to reverse the poles. It snaps to the bottom immediately. This shows the levitation depends entirely on the magnetic poles, not a hidden trick. Feeling that resistance confirms the force is active, even without a visible connection. It proves that movement doesn't depend on physical contact. The same principle is what allows massive commuter trains to hover above their tracks and travel at high speeds. Magnetism is just one part of the family. This diagram shows how the theme connects to other forces. Gravitational force and electrostatic force work the same way, acting on objects without ever touching them. Vaibhav finally admits it. Chalo, it's time for those samosas. We'll cover static electricity in the next video. Subscribe to Physics Sensei for part 2. Understanding non-contact forces gives us a way to move objects across empty space, from tiny atoms to entire trains.